Okay, this is a series of videos that are going to go through the homework for the unit on implicit differentiation. Problem number one, x squared plus y squared equals 36. I'm not going to spend a lot of time trying to describe what I'm doing. I think that came through in the introduction videos. I'm just going to go through it real quick. All right, so we're going to differentiate both sides with respect to x. And what that means is we're going to take the derivative of both sides of that equation there. Note that, and I keep saying this, I'm taking the derivative with respect to x. So that means whenever I see an x inside the expression, I just treat it normal. If I see something other than an x in there, I have to treat that as if it were a function of x, and so I'm going to use the chain rule with that. Alright, so we're going to differentiate x squared plus y squared, and that is 2x plus 2y. Now, if we were differentiating with respect to y, it would just be 2y. But because we're differentiating with respect to x, we treat y as if it's a function of x. And so we're raising some function to the second power. So we have a chain rule. We have function composition. The outside function is something squared. The inside function is f of x. We take the derivative of the outside, which is 2 times whatever the inside was, reduce the exponent to 1, and then multiply that by the derivative of the inside function, which was y, and the derivative of y is just y prime. Alright, the derivative of a constant on the right side is always 0. Don't forget that. And from this point, it's all algebra. All we're going to do is try to isolate that y prime. And so we do that the same way we would do with any other variable that we're trying to isolate. We get rid of addition and subtraction first, and then we divide both sides by 2y, and we get y prime is equal to negative x over y. Now you should see, and you could try this out, change that radius squared to any other number. It could be 36, it could be 9, it could be 25, it could be 4, it could be 1. When we do this, we're always going to get the same exact derivative from that. Alright, this is problem number one. I'm going to go on to problem number three. Okay, in problem number three, we want the derivative of x to the 1/2 plus y to the 1/2 equals 9. And we're going to go ahead and take the derivative of both sides with respect to x. Now, when you're first starting out, I would really suggest that you take the extra second of time to rewrite the problem like that so that everybody who's reading it can see clearly what you're doing. All right, now we're going to take the derivative of both sides. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. And the derivative of y to the 1/2 is going to be the same, except we're going to multiply by y prime in the end. So it's 1/2 y to the negative 1/2 times y prime. And the derivative of a constant is always 0, so we get 0 on the right side. Okay, all the calculus work is done now. At this point, we're just trying to isolate our variable. And so we get rid of everything attached to it, get rid of addition and subtraction first, multiplication and division second. So we move the 1/2 x to the negative 1 over 1/2 over to the right side, made it negative. At this point, we can multiply both sides by 2 or cancel the 1/2s regardless. The 1/2s go away. Alright, now we're going to divide both sides by y to the negative 1/2, and we end up with y prime is equal to x to the negative 1/2 over y to the negative 1/2. And just remember that x to the negative 1/2 really means 1 over the square root of x, and y to the negative 1/2 means 1 over the square root of y. And so however you want to look at this, now we're dividing fractions. We can take the reciprocal of the denominator, multiply it by the numerator, and we would get, sorry, that whole thing is negative there. So I added those negative signs on. When I multiply the numerator by the reciprocal of the denominator, now I'm going to get negative square root of y over square root of x. And I can leave it as 2 square roots. I can make it 1 whole square root. I could rationalize the denominator, etc. That's good enough for our purposes here. Okay, so that's problems 1 and 3. And we'll go on in the next video to the next problem 5.